Hello and welcome to our mathematics lesson. We continue to do on the topic on properties of geometric figures. Today we want to cover two subtopics in this particular lesson. The first one, we are going to look at enlargement and similar figures. So during this particular topic, we are going to look at how we can be able to enlarge some particular figures or objects from the small to very big and very large figures. From there, we shall also be able to look at similar triangles. And this particular aspect, we shall be interested in the areas of stating whether triangles are similar, and if they are similar, what properties should those two particular triangles portray or contain. So we're going to first look at the enlargement and similar figures. Now, whenever the question of similarity is put into test or question, then we discover that we are talking about similarity in terms of shape. The size in this particular case might not matter. So we must be only interested with the shape of those two particular objects. If the shapes are the same and they are of different sizes, then we say that those particular objects are similar. So we are saying that similar figures have similar shape irrespective of their sizes. So they can be of different sizes, but so long as they are of the same shape, then we can be able to refer to them as being similar. We can also be able to say that these two shapes are going to be similar if they have the same shape, but if they have got different shapes or size, then we can be able to say that enlargement was put in place or was applied. And this enlargement can be either negative enlargement, where from a big shape, from a big size, we obtain a small size, or it can be a positive enlargement, where from a very small object or figure, we can be able to obtain a very large figure. So two figures are similar if an enlargement of one is identical or congruent to the other. So long as the two figures in questions are similar, that means they portray the same shape irrespective of their sizes, then you can be able to say that enlargement has been done on those two particular objects. And therefore that puts us to this: what is enlargement? And what are these types of enlargements that we do have for bringing a small objects to a bigger objects or bigger objects to smaller objects? Enlargement is simply a transformation. So you can be able to say that enlargement is a transformation that involves increase, increase or decrease in size of an object. So whenever we have an object, then we either increase it, maintaining the same shape, or we decrease it, still maintaining the same shape. Then we are going to result to what we are referring to as an enlargement. So it is simply a transformation. Now, the shape of the object, we should be able to appreciate by now that the shape will remain the same. That is, it will remain unchanged. The shape of the object remains unchanged during enlargement. So it remains the same. This enlargement normally makes good use of two aspects. One is the center of enlargement, and two is the scale factor. The scale factor can either be negative, meaning it will transform a big object to a small object, or we can have a positive scale factor which will transform a small object to a big object. Then the center of enlargement is that particular point where all the transformations is beginning from. So enlargement uses or makes good use of center of enlargement and an enlargement scale factor, which we are saying it can be small or it can be big. If we had an object, let me use the case of a triangle. Then we decide to enlarge this particular triangle. So our original triangle was ABC, but we have enlarged it so that we have A prime, B prime, C prime. So you can be able to see that this triangle is much bigger than this triangle. This point where we began the enlargement from is where we refer to as the center of enlargement. Now for us to be able to get the scale factor that was used, then scale factor will be given by the image distance over object distance. And that particular object distance and even the image distance is normally taken from the point of enlargement. So like for example, if you are referring to as the image distance for point A, then it should be the distance from O to A prime. Then its object image or the object distance will be from O to A. So in this case, you can be able to say image distance of A, that will be OA prime over OA, and all the ratios should be the same for us to be able to have a similar object. So it should be equal to OB prime all over OB, which is the object distance for point B, and this should again be equal to OC prime all over OC. This will give us the enlargement scale factor for which we can be able to calculate, or for which this particular object ABC has been enlarged to A prime, B prime, C prime. And we are saying that still we could reverse this process and have a smaller image if we were originating, or if our center of enlargement was on the other side or still on this side, then the scale factor has a negative, is negative, or it has got a negative ratio. The next important thing is that two figures are similar if one can be changed so it can be enlarged, if one can be enlarged to be a congruent to the other. And therefore, if they must be congruent to the other, one is that we must have matching angles being equal. The matching angles of those two figures should be equal. Two, we talked about the aspect of the sides, and we say that pairs of matching sides are in the same proportional. The pairs of the matching sides should have the same proportion, or simply the ratio. So we had said that the enlargement scale factor will always be given by the image length, or length of image, over the object's length. The object length. You can be able to recall our two similar triangles where we said this is AC, this is A prime, C prime. So you can be able to say that these pairs are of the two pairs are matching sides, and therefore for us to be able to get the scale factor, you will take A, C, which are matching, all over AC, which is the length of the object, and of course should be equal to the other pairs of the matching sides. Now here, there are three things that we need to note. One is that the scale factor is between, if the scale factor is between 0 and 1. That is, we have maybe 0.1, 0.2, 0.3, up to 0.99999. Then the image you're going to obtain will be smaller than the original object. Then the image will be smaller than the actual or original object. That is if it is less than 1 but more than 0. The second point on the scale factor, what if the scale factor is greater than 1? So if the scale factor is greater than 1, that means it can be 1.1, 1.2, it can be 2, 3, 4, 5 to infinity. Then the image of the object is bigger or larger than the original object. Then the last point on the issue of the scale factor is, what if now the scale factor is equal to 1? That means the figure will be transformed back to itself, and therefore we shall not have another shape of a different size being formed. So if the scale factor is 1, if the scale factor is 1, then the image and the original are congruent. That means one can match exactly into the other one. There is a symbol that we normally use to indicate similarity. This symbol is 3 strokes. So whenever you see 3 strokes, it means that one object is similar to the other one. Is used to describe similarity. For example, if we had 2 triangles, quadrilaterals of this form, then we have a much bigger one. Then we are told that this is 100 degrees, this is 80 degrees, 100 degrees, 80 degrees, 140, 40, 140, 40. That this is a DC, AB, and this is Q R S T. So if you look at these two objects and you compare the angles in each of these, you'll discover that all the angles are equal, and that will simply tell you that these two quadrilaterals are going to be similar, with some pairs of the sides which are going to be equal. I mean to be congruent of the others. Now in this particular case, because of that incidence, we can be able to say that this quadrilateral is similar to this by use of this sign or symbol, and therefore we can be able to say that A, B, C, D is similar to Q, R, S, T. Then for you to be able to get the scale factor, then we use the pairs of the corresponding sides, like DA corresponds to TQ. Therefore, we can be able to say that the image, which is TQ all over DA, is equals to another corresponding side. We can take QR, so QR all over AB, which is equals to, we can take another pair, RS all over, RS corresponds to BC, which is equals to ST over CD. Those particular sides corresponds to one another. Now, if we were told that this is 10 units and that this is 5 units, what could be our scale factor? So the scale factor will be equal to QR, which is the length of the image divided by the length of the object, which is AB, and that will be 10 over 5, which will have given us 2. And again, 2 is greater than 1, and that means, or you can be able to see that it were able to transform a smaller object to a much bigger image. Let us look at an example on how we can be able to use enlargement to solve different problems. These figures below are similar. So we are told that the figures below are similar. The first question is, let me first draw them. We are told that these two figures are similar and that this is the original, while this is its image. From here you can be able to see that the image is much bigger than the object. Now on the image, this side is 3 centimeters, this side is Y centimeters, this is 4 centimeters. For the other one, this is 6 centimeters, this is 7.5 centimeters, and this is X centimeters. So the first question is, find the scale factor. Number 2, find the value of X. Number 3, find the value of Y. Now we are told that these two particular figures are similar, and given that they are similar, that means they have got pairs of corresponding sides which are going to be in congruency. That means their lengths are going to be in proportion to the other. Now, to be able to answer the first question, which requires us to find the scale factor, we were told that scale factor will be given by image length all over object length. So the only work that is here is for us to be able to find the corresponding sides. And from this, we can be able to see that the object has been inverted, so that these particular points goes there. And given that this side and this side are equal, that side and that side are equal, then we can be able to say that this particular point corresponds to this particular point. The base will now correspond to this, and we are told that this is 4 centimeters, that is 6 centimeters. So let us use this because all of them have got the measurements. So in this case, the length of the image is going to be 6 units. We divide it by the length of the object, which is 4. And this will result to 1.5. So this tells us that the scale factor that was used to enlarge this particular object was 1.5. And it is actually a positive scale factor, and that explains why why the image is bigger than the original object. Number 2, we are supposed to find the value of y. We are also supposed to find the value of x in part 3. Now, for us to be able to find the value of x, we had said that x corresponds to this other, which is 3 units. So we can be able to say that 3, we take the length of the image, which is x, you divide by the length of the object, which is 3, it should give you the scale factor, which is 1.5. And this tells us that for us to be able to find the value of x, we must multiply both sides by 3. And this will give us 4.5. So that tells us that this side is 4.5, that side is 4.5. The last question, find the value of y. We understand that y corresponds to 7.5 on the image, and therefore for us to be able to find the value of y, then again we use the formula for finding the scale factor, which is the image length over the object length. The image is 7.5 all over, it corresponds to y, and it should be 1.5. So that means for us to be able to find the value of y, we need to multiply both sides by y and divide both sides by 1.5, and that will give us y to be 7.5 divided by 1.5, which will be equal to 5 units. So this will be 5, that side will be 5 units. So you can be able to appreciate that we apply or we use the scale factor in so many ways for us to be able to solve questions that touches on enlargements. Example 2. We are told that for the following pairs, find 1 a scale factor, 2 the value of x, and 3 the value of y. So the shapes it is that is 0.8 units. The radius is 0.5 units. This side is x. Then we have a much bigger figure. We are told the radius is 1.25. Then we are having the longest side. So this one is 1.5. This side we have got y. Now, for us to be able to answer these two questions, or this particular question, we need to understand that these two figures are similar. Both of them are the semicircles, and we have got pairs of corresponding sides. Like you'll be able to see that x corresponds to the other shorter side, which is 1.5, 0.8 corresponds to y, and the radius 0.5 corresponds to 1.25. We are going to use, for us to get the scale factor, we're going to use the one that we have got both the image length and the object length. And therefore the scale factor is going to be equal to the value or the image length, which is 1.25, divided by 0.5, which is the object's length. And this will give us 1.25 divided by 0.5 will give us 2.5. So the scale factor that was used in transforming the object to the image is 2.5. Part 2, they want us to find the value of x. And as we had said, x corresponds to 1.5. And for us to be able to get the scale factor, which is 2.5, we take the image length over the object length. It should still give us 2.5, which is our scale factor. So that means for us to be able to get the value of x, we need to multiply both sides by x, then divide both sides by 2.5. That will give us x to be 0.6. The last part, the value of y, we are again going to use the corresponding sides, that is y and 0.8. And in this particular case, when you take the image over the object's length, it should give us the scale factor, which is 2.5. So this means that for us to be able to get the value of y, we need to multiply both sides by 0.8. And this will give us y to be 1.6. So that is 1.6 units, which is the much longer side. Example 3. We are told that a person 1.8 meters tall stands in front of a light that sits on the floor. The person casts a shadow on the wall behind him. The question is, how tall will the shadow be if the distance between the wall and the light is 4 meters. So here we have a question where we have got a person who is 1.8 meters tall. So let that be that particular person, 1.8 meters tall. And we are told that he is standing in front of a light. And this particular light is sitting on the floor. So once those rays of the light will begin hitting the man, he will cast a shadow to our wall. This is the ground, and we are told that the distance between the light and our man is 2 meters. So the first question, the question is, if the distance from the light up to the wall is 4 meters, what will be the length of the shadow this man will be casting on the wall? So the same, we need to apply the importance of the aspects of the scale factor. As you can be able to see, we are having 2 triangles here. We have got this triangle, which is similar to this other triangle, and this side corresponds to this side. The wall of this corresponds to the wall of that. And that means that for us to be able to get the scale factor in this case, you will be able to take the image distance, which is 4, all over the object distance, which is 2, and that will give you 2 units. And therefore, for us to be able to get the value of x, then we are going again to use these corresponding sides, x and 1.8, that when you take x, which is the image length, we divide by 1.8, which is the object length, we are still going to get 2. That means that x will be 2 multiplied by 1.8, and that will give us 3.6. So x is equals to 3.6 meters. So this tells us that this particular person is going to cast a shadow of 3.6 meters on the wall. the final question, example 4. We are told an object is enlarged by a scale factor of k. What is the scale factor, or what is the scale factor that should be used to reverse the enlargement, reverse the enlargement in question. So we are told that when you have an object and we use a scale factor of k, we enlarge it. So the question is, what if we want to reverse so that we still end up with the original object? What scale factor should we be able to use? So in that case, if this was AB, this will now be our CD, no, our A prime, B prime. So initially, A1, B1 over AB was K. Now, what if you now want to reverse so that now this is your object and this becomes your image? That means whenever we'll be reversing, so that we have this as A22 and this to be B22. So that means we are going to inverse. So that we begin from A prime, A double prime, B double prime, all over A prime, B prime. And that will tell us that we must also inverse the scale factor to 1 over k. So for us to be able to reverse the process of enlargement, we should use the scale factor of 1 over k. That is the inverse of that one, k. So let us look at another subtopic on similar triangles. Now there are some points that we need to note concerning similar triangles. That is, two triangles are similar if we have two conditions. One is that the matching angles are equal, and two is that matching sides, the matching sides of those two triangles are in the same proportion, are in proportion. That is to say, they are of the same ratio. The similarity statement still remains. Similarity statement uses still the three strokes. That is to say, one triangle is similar to the other one. The example given is that if ABC is similar to another triangle DEF, then we use the three strokes, triangle DEF. So in this particular case, we shall be saying that triangle ABC is similar to triangles DEF. We want to look at the tests for similarity in triangles. Test for similarity in triangles. Now there are four main tests for similarity in triangles. One, or test one, is if the three sides of a triangle are proportional to the three sides of another triangle, then the two are similar. So that aspect is that if you have two triangles, maybe this is 3 units, that is 6, this is 8 units, this is 4, and that this is let's have it still 6, and this is 3. So you can be able to see that the pairs, all the three, this and this, will give you the same ratio as this, and this will give you the same ratio as this and this. That is 6 over 3 is equals to 8 over 4 is equals to 6 over 3, which is equals to 2. So in that particular case, you'll be able to say that this triangle is similar to the other triangle. Test 2 is now on a side, and two sides of a triangle. So if two sides of a triangle are proportional to two sides of another triangle, and the included angle are equal, then the two triangles are said to be similar. Now in this case, we talk about two sides and an included angle. So that, for example, if we have these two triangles and we are told that this side and this side are in proportion, also this side and this side are in proportion, and the included angles are the same, then we can be able to say that the two triangles are going to be similar. Number 3, or test 3, if two angles of a triangle are equal to two angles of another triangle, then the two triangles are similar. So in that particular aspect, two angles are equal. then we have got one side that is going to be equal, then that will automatically take you or tell you that those two triangles are going to be similar. Then the last test is on the hypotenuse, the second side, and the right angled, that is the RHS. If the hypotenuse and a second side of a right angled triangle are proportional to the hypotenuse and second side of another right angled triangle, then the two triangles are said to be similar. So these are the four main critical tests that we normally use to test whether triangles are similar. We are going to look at one example for us to be able to use these tests to solve a question that involves similarity in triangles. So let us look at one example for us to be able to use the test to solve a question in similarity of triangles. So we are supposed to choose a similarity test. To choose a similarity test that proves pairs of triangles given are similar. Number one, we have got these pairs of triangles where we are told that this side is equals to that, this angle is equals to that angle, and this angle is equals to that angle. B, we have a right angle triangle and another right angle triangle, that this is 6 units, the longest side is 9, this side is 3, and this side is 2 units. So I want to see which tests suits either of these. So in the first case, we are going to use which test, where all the angles of the first are equal to all the angles of the other one. So we use the first test, which states that if all the pairs of the corresponding angles are equal with the angles of another triangle, then they are going to be equal. So in that particular case, we use test 3, which was talking about all angles equal. Then for number 2, we have a right angled triangles. That will definitely tell you that we'll use the last or test 4. And you can be able to see that the corresponding sides, the two corresponding sides are congruent, That is, if you take 6 over 2, you are going to get 3. If you take 9 over 3, you are going to get 3. So that is test 4. That is 1. Both are right angle. Then hypotenuse and the sides are proportional. The sides and the hypotenuse are in proportion. So that brings us to the end of our discussion on the two, that is similarity of triangles. And in similarity of triangles, don't forget about those 4 main aspects or tests for similarity in triangles. Then we have also been able to look at how we can be able to solve problems that involves enlargement and also in similar figures. Next time when we meet, we shall be able to look at the proof and how we can be able to make the application of similarity in triangles. Thank you.